Hey, so today we're going to learn the first part of solving quadratics, which is two ways. There's 4 ways total. Today we're going to talk about graphing and factoring and what that means in terms of solving. Okay, so the first thing that we need to understand is, what does solve mean? Well, if you notice, all of these 3 examples are all set equal to 0. And so basically what that means is that if we think about it graphically, that means obviously all of these are parabolas. You should know that by now. So we're going to have a parabola that's going to cross through, could possibly cross through the x-axis. So where it says where it's equal to 0 means the y value is 0. That means I'm plugging in something and getting out 0. And so this point and this point would be those places. Now, this is so important that it does have its own chapter, and lots of different things are called solving. So, for instance, some words you're going to hear are the word root. These 2 points are roots of the equation. You're going to hear zeros, and a couple other, and solutions, of course, a couple other different names that we call it. But basically it's where this parabola crosses the x-axis. So if we think about it, let's say that this is at 0, 0. Okay, that makes sense. Then let's say the other root is at, let's just say 2, 0. Notice that my y values are 0. So when we're solving, it's very important that we make sure that the equation is equal to 0, because that will give us the x values of these 2 points. Okay, so the first way we're going to learn how to do this is with a graphing tool, which is online. So I'll show you how to get there, and then you should be able to do it with no problem. Now, to get to Desmos.com, what we have to do is go in and type in Desmos, D-E-S-M-O-S, and then .com. I'll show you what will happen the first time that you go in. It won't go straight to the calculator, so oh, well, maybe we'll go straight to the grapher. So we'll see. You may have to click on their home page. You may have to click in the middle. It says Start Graphing. That would be the only difference. I've already been there a bunch of times, so my computer takes me straight there. So anyway, so what we can do here in this grapher is, if you look over here on the left, there's places that we can type in functions. Now, we do have to name the function, so like in most cases we're going to call it f of x. See if I can get all my symbols here. F of x, and it kind of leads you along the way as you work. So this is going to be once I do that part, what's down here at the bottom is a little nice key that will help us plug in things that we need. So the first one that we are solving today, so I can find the question again, was x squared minus 2x. So I'm going to type in x, and if you look over here at the this a squared, that gave me my squared. So I'm typing in x squared minus 2x. And so what's happening is it's graphing the function as I plug it in. Okay, and what's really cool about this grapher is you can, sometimes your graph won't be where you can see it, and so if you just take your fingers or your mouse, or even over here on the plus and minus keys, you can make it larger and you can make it smaller. You can touch and drag and move it around. So in this case, and notice how it will pinpoint these points right here. So I can, and obviously I can look at this and tell that it's 2, 0, but there's going to be some that might be decimals or fractions, and it's harder to see. So in answering the questions that we're trying to answer, we want to know where this function is equal to 0. So that would happen here at 0, 0, and here at 2, 0. So my answers would be 0 and 2. And that's just one way to solve. That's the graphical way. There's also algebraic ways that we're going to learn throughout this chapter. We already did A in the Desmos grapher, and we noticed that the answers to that were 0 and 2. Okay, so that means that graph crossed the x-axis at 0 and at 2 on the x-axis. All right, so okay, for question B, I went ahead and graphed it in Desmos and then just did a picture of it. So we could talk about the root or the 0, however you want to call it, but basically we want to know this is equal to 0. So the place that this crosses the x-axis is here at x equals 1. So your answer in that case would be x equals 1. All right, and the next one though, here's your 0, 0, and after I graphed it, I noticed that this function actually will never cross the x-axis. So in that case, right now, that is called a no real solution. What happens is you end up having imaginary solutions there, and those are going to come up later in the chapter. So if you look at our 3 options here, we could have 2 solutions. Now think about this. Could a quadratic ever have more than 2 solutions? I hope that you said no, because if a quadratic or a parabola looks like this, it's only possible to hit at 2 places. It can't cross any more than that. All right, so it could be 2 solutions. We could have 1 solution, like in this case, where it only touches at 1 place. And then we could have no real solutions where it doesn't touch at all. It's above the x-axis, basically. All right, on that same page, we have a few more downward-facing parabolas that give us the same idea. I've already matched them with the correct graphs that are on page 45. So this one here matches this graph. And so what happens is we end up with the same thing. We end up at x equals 0 and x equals 2 once we look at the graph. All right, and this one we have x equals 1 because it crosses at 1. And this one would be a no real solution. All right, and now the fun part, and that is solving these things algebraically. And there are a couple of different ways to do that. Right now, we're going to learn factoring because you just took a test with factoring on it in order to prepare you to be able to do that. So what's going to happen is after you factor, so I'll say the second step would look something like this. Let's say you factored and you got this. So remember it's equal to 0, so I'm going to leave that equal 0 there. All the 0 product property says is that only one of these things has to be 0 in order to get 0. See, it says A times B. If that's going to be equal to 0, A could be 0 or B could be 0. So we're going to take this first thing, which we would call A in the case of the, sorry about that, obviously I'm at school doing this on the professional day. So we could set up A plus 1 equal to 0 or x minus 3 equal to 0. Either way, that would make this equation equal to 0. So when I solve this, I'm just going to subtract 1. Ooh, bad color. So one of my roots will be x equals negative 1. The other one would be x equals 3. So I would have 2 solutions in this case. All right. The other way, actually it's not another way, it's the same thing, but this always throws students off, so I want to show you what happens. Let's say I factor a Lizzie method problem, and I end up with something like this. We still want to take this 2x minus 1 and the x plus 1 and set it equal to 0. So what's going to happen is students start to figure out really quickly that it's just the opposite, because I'm subtracting 1. So then they'll get in the habit of going, oh, well, x plus 1 equal to 0, that's just x equals negative 1. And then we stop showing steps. And then what happens is you end up with one like this on the left, and then students will say, oh, it's x equals 1, because they're looking at this part saying that it's the opposite, but it's not. I want to add 1 to both sides, and then I have to divide by 2. So my answer is actually 1/2. Okay, so we just want to be careful with that. All right, now we have a couple of examples that will work from beginning to end. I would suggest that you put these down in your notes. I do not think, no, these are not in your workbook, so you're going to want to use that space that you have on page 47 and the space you have on page 47 and put it down in there. All right, so pause it as you need to, but I'm going to start working. All right, so the first thing I see is that it's already set equal to 0. That's the first step. Now I'm going to start factoring. This is where you have to have your factoring methods. This one has a equal to 1, which means I'm just going to start with x and x. I want the factors of 5 that add to give me 6. So factors of 5 that add to give me 6 will be 5 and 1. And I want it to be a negative 6, which means they both have to be negative. Now to finish this out and get my actual solution, I'm going to have to set both of these equal to 0. So that gives me x equals 5 and x equals 1. So what that means is that my roots are at 1 and 5, and this parabola looks something like that. Okay, and of course that's just a quick sketch. All right, so the next one, same thing. We have a trinomial where a is equal to 1. We use x and x. I want the factors of 9 that add to give me 6. Factors of 9 that add to give me 6 are 3 and 3, and I want a negative 6. So they both have to be negative. Now in this case, both of my answers give me the same thing. I get x equals 3. So what that means is that it's going to cross through at 3 and look something like that. Okay? Right, now my next one is, hopefully you recognize it already, but this is a difference of squares. So if you know your factoring methods, that would be x plus 5 and x minus 5. Therefore, when I set these two equal to 0, x would be equal to negative 5, and it would also be equal to positive 5 after I add 5 to both sides and subtract 5 to both sides. And something you want to make sure of is that your function is always set equal to 0. First of all, it would be hard to factor anyway if it wasn't, but remember the idea is that we're finding where the y value is 0. So in this case, what I would have to do is subtract the 6 over to the other side. So when I rewrite this, it will be minus 6 equals 0, like that. All right, then again, it's going to be a factoring. I want the factors of 6 that subtract to give me 1. There's a positive 1 in here. That would be 3 and 2. And I want it to be positive, so 3 is positive and 2 is negative. Again, that's why you have to be able to factor, and we did that in the last chapter instead of waiting until now. All right, so my two answers would be x equals negative 3 and x equals 2. All right, and then in the next one again, I have it's not set equal to 0, so I must do that first. Now, I want to be careful when I set this up, though, because when I subtract minus 5x, I know with factoring, I want it to go right here in the middle. I don't want it to go at the end. I need it to be set up so that I can factor it. So I'm going to make that minus 5x go next, then minus 3 equals 0, like that. Now hopefully you recognize this is a trinomial with a bigger than 2, so I'm going to have to use the Lizzie method. So this will 2 times 3 would be 6. The factors of 6 that subtract to give me 5 would be 6 and 1. I would need it to be a negative 6 and a positive 1, and then don't forget to divide by a. So in this case I would be negative 3 over 1. Don't need that anymore. So my answer would be 1x minus 3 times 2x plus 1. I still have to remember to set that equal to 0. So I did all that work and it's not even solved yet. Now I have to set it equal to 0. So I'm going to set x minus 3 equal to 0 and 2x plus 1 equal to 0. When I add 3 on both sides, x is 3. This is the one where I was saying you have to take 2 steps to get there. So x is negative 1/2. So what that means is that this parabola crosses through the x-axis at negative 1/2 and also at 3.